For this example, we'll use intercepts and end behavior to analyze the graph of a function. So we have a picture of a graph here, and we want to use the end behavior and the intercepts to explain why this graph cannot be the graph of f of x equals x to the fifth minus x. So let's first of all start with the end behavior. With the end behavior, for the graph of f of x equals x to the fifth minus x, we look at the leading coefficient. It's the coefficient with the highest degree, in this case x to the fifth. It's positive and the exponent is odd. Whenever we have a positive coefficient with an odd exponent, the end behavior is up to the right, down to the left. In other words, it rises to the right and falls to the left. In this case, that's not happening here. This rises to the left and falls to the right. So by the end behavior, the graph of f of x equals x to the fifth minus x cannot be this graph. Let's also look at the intercepts. In order to calculate the intercepts of f of x equals x to the fifth minus x, we need to factor it. We factor out an x, and we have x to the fourth minus 1. That factors further because x to the fourth minus 1 is the difference of two squares. So we have x times the quantity x squared plus 1 times the quantity x squared minus 1. Factors even further because x squared minus 1 is again the difference of two perfect squares. So we get x times x squared plus 1 times, if we factor x squared minus 1, we get x plus 1 times x minus 1. Now, we can look at each of these factors. We have three linear factors, x, x plus 1, and x minus 1, and we have one quadratic factor, x squared plus 1, that cannot be factored further. So let's look at each of these individual factors and set each one equal to 0. If we set our first factor, x, equal to 0, that gives us one of our intercepts. So x equals 0 is an intercept. If we set x plus 1 equal to 0, we'll get x equals negative 1 as our next intercept. And if we set x minus 1 equal to 0, we'll get x equals positive 1 as our next intercept. Let's talk for just a minute about this quadratic factor, x squared plus 1. If I set x squared plus 1 equal to 0, I'll get x squared equals negative 1. There are no real solutions to this equation, so therefore this does not provide me with any x-intercepts. So I know that the graph of f of x equals x to the fifth minus x has the intercepts of 0, negative 1, and positive 1. However, this graph has x-intercepts of 0, negative 2, and positive 2. So therefore, by the end behavior and by the intercepts, this particular graph cannot be the function f of x equals x to the fifth minus x.